Okay, what we're going to do here is just have a brief look at bile movement from the sinusoid. Remember, that's where blood's flowing from the portal vein to the sinusoid, and then how the bile then moves back into the canaliculus. Now remember that most of the bile is absorbed in the small intestine at the ileum, so it's recycled. So you really only synthesize a small amount of bile. The rest of it is recycled. So 90 to 95% of bile acids are recycled from the GI tract. They absorb, enter the portal vein, and eventually enter the sinusoid. Both conjugated and unconjugated bile acids are transported into the hepatocyte. And there are a number of different mechanisms for doing this, and this is what we'll look at in the next slide. As you can see here, I'll quickly orientate you. If you look at the little arrow here, we have the sinusoidal space on the left, the hepatocyte, the caniculus is this little white area here, and the thing to remember is that most conjugated bile acids are co-transported into the hepatocyte with sodium, so therefore it's a secondary active transport mechanism. So the CBAs, conjugated bile acids, let's have a look. There goes one, there goes two, but also as well, you'll also see some unconjugated bile acids are also co-transported with sodium. Not a great amount, but some of them are, so just be aware of that. Now, most people believe that there is a concentration gradient difference, that you have less concentration in the sinusoidal space when compared to the hepatocyte. So therefore you require energy to move the bile acids into the hepatocyte. So as you can see, as well as sodium transport, using the sodium gradient to get the bile acids into the hepatocyte, we also have what are called organic anion transporting polypeptides, or OATP, that transport bile acids into the hepatocyte. Now these seem to favour the movement this time of the unconjugated bile acids, and a greater proportion of the unconjugated bile acids will move into the hepatocyte via these organic anion transporting polypeptides. However, they're not exclusive. As well as this, they will also move in some of the conjugated bile acids as well too. Interestingly, they don't require ATP or sodium, and their precise mechanism of action of these OATP proteins is unknown, though it's been suggested that maybe a bicarbonate exchange might be involved and help in the movement of the unconjugated bile acids against their concentration gradient into the hepatocyte. Next, well, once inside the hepatocyte, the conjugated bile acids are most likely moved to the caniculus using bile acid binding proteins. So you have proteins within the hepatocyte which bind these conjugated bile acids and take them directly to the canaliculus so that it can then enter. The unconjugated bile acids need to be conjugated first, so they're immediately conjugated and then they're shuttled, as their conjugated cousins are, to the canaliculus. Now, before we look at the movement of the bile acids into the canaliculus, we have to remember that the concentration of free conjugated bile acids inside the hepatocyte is approximately 1,000 times less than that of the canaliculus. So that means that in order to get these bile acids into the canaliculus, you're going to have to use some form of energy source in order to do this. So most of the conjugated bile acids are co-transported into the canaliculus via what's called the bile salt export pump, or BSEP. And this is an ATP binding cassette protein, or ABC transporter, that you should have heard about before. So using ATP, what it will do is it will move the conjugated bile acid against its concentration gradient into the canaliculus, as you can see. There's also another protein that will do that, which is called multi-drug resistance protein, or MRP2, and this is another ATP binding cassette protein, and as you can see, it will move that in. So now we've got the conjugated bile acids into the canaliculus. Once they're conjugated, the bile acids find it difficult to passively diffuse across plasma membranes. So therefore, we use a transporter to get them in to the canaliculus. But now once in there, they're trapped because being conjugated, they find it very, very difficult to cross the plasma membrane down their concentration gradient to get back into the hepatocyte. So therefore, under normal conditions, once you've moved the conjugated bile acid using the ABC protein, getting it into the canaliculus, it can't move out.